Hello everyone. Welcome to the live stream for this amazing stream where we will deploy our web application to Microsoft Azure. And we will also use different tools such as GitHub Actions to automate the deployment process. We'll see how this all fits together, and we will see a live demo where all this happens in a real example. So it's going to be a lot of fun. So I'll just wait for a few more seconds for the folks to join in, and then we can get started. I hope you all are excited. Let me just quickly pull up my screen. I hope you can see my screen as well. So I am pretty sure that you all have built some sort of the web application before in your career or your student life as a student project, or even during this global hack week or any other hackathon. Even if you have not, then we have a sample repo where you can clone the application, and then we'll get started. Okay, I guess we can start now. So let us quickly start the session. So hi everyone, I'm Sagar. I work as a coach at Major League Hacking, and in terms of my professional career, I am mostly into cloud and DevOps side of things. So I take care of the deployments and also the server side things for most of our client applications. And I'm also super excited to start my master's degree program at the Technical University of Munich this winter. So super excited for that and looking forward to join there as well. So if you want to connect with me, I am mostly active on Twitter and my Instagram. You can find my handles and so in the slide. So I am super happy once again to welcome you all to the Cloudland, and I am happy to have you all here. Trust me, it's going to be a lot of fun. You will see a really cool example of automating the entire process, right from pushing your changes to the GitHub repo to making sure that those changes are deployed in a live production environment in Microsoft Azure, and also to make sure that every time you make a change, you don't have to log into the server and update the changes manually. So everything will be configured automatically by the GitHub Actions pipeline. So we'll be using different Azure services. We'll see all of this in just a second. Super important information for you all is that please make sure to bookmark this specific link. I have compiled some important instructions as well as the resources that we will be using in this session in this specific link. It's a Notion page. So you'll get a lot of information about this session. I'm also just quickly gonna put this in the comments so that it's accessible for you all. So please make sure that you bookmark or follow the instructions in the this Notion page as well. All right then. So just a breakdown of the session and what we are going to do today. So first, we'll just quickly and briefly look at the different cloud service model. I am pretty sure that by now you have you might have already attended some of the other global hack week sessions and you already know about this, but I'm just going to quickly recap about that, and then we'll talk about the specific Azure services, mostly the Azure App Service, which will be used for our backend application, and the Azure Static Web Apps, which we will use for the front end, which is React in our case. So we'll also talk briefly about GitHub Actions and how a typical workflow looks like, and then we have a lot of demos. Like I want this session to be a really hands-on and also showcase you the practical side of things rather than just the theoretical stuff. So we will have a demo of how you can create your MongoDB database in the cloud using MongoDB Atlas. I guess you might have already used that. So it's a NoSQL database. So we're going to see how you can set up a database cluster in cloud. We'll also run the sample Mon application that I have put up there in my GitHub repo. So you can clone it. You can also do the same steps for your own Mon applications, by the way, or the process is very similar if you have a different stack application as well. You just need to change some of the configuration, but everything else works fine. If you don't have it yet, then we will have, I do have the sample repo that you can simply clone and follow along. We will create different Azure services, and then we will also finally end up with automating the deployment process. So let's get started. So firstly, talking about the different cloud services. So these are divided broadly into three categories. The first, we have the infrastructure as a service. So it's basically you have the most control in it as you are simply renting out the different hardware resources and the infrastructure from the cloud vendors such as AWS or the Microsoft Azure or Google Cloud. So let's say you just rent a server rack, and then you configure the operating system in it. You install your virtual machine by yourself. You take care of these different network configuration. You take care of the updates and everything. So basically, if you want to just get a bare metal device rented out by the cloud providers, then that is what we know as the infrastructure as a service, or in short IaaS. So you have the more control, but also it comes with some sort of a complexity that you have to deal with, and you need to be really careful with this configuration. Otherwise, things might go on. But in the long term, if you manage it with, it's a really cost-effective manner to do things. And then we have the platform as a service, also known as the PaaS. So that's going to be on the middle side of the thing. So you don't lose all the control as well, and also you don't have as much flexibility as you would have got in the infrastructure as a service. So it's like in the middle. Just take an example of the Amazon EC2 instance. So that's a virtual machine in the cloud, or also the Azure VM, Azure virtual machine. So you don't need to take care of the hardware level stuff. So the installation of the hardware, the network configuration, the regular updates for your operating system. So all of that is taken care by the cloud service provider, and you can just simply connect to the VM and then use it to your needs, whether to deploy an application or to use it as a backup server, anything that might be your requirement. So all of the underlying low-level stuff is taken care by the cloud service provider, but you get the most flexibility. And finally, you have the software as a service, which is mostly focused on abstracting away all the unnecessary complexity. So you don't even have to set up a virtual machines or things like that. You just basically get a software that you can use on the go. A good example could be Heroku. I guess you has used that. You must have used that to deploy your hobby project, or also Vercel. So you just deploy your code, and everything else is taken care by the cloud service provider, right? So you don't even need to worry about how to configure different things. You just connect it to your GitHub repo or any other source code repo, and then everything goes away. So that was just a quick recap of the cloud service model. And the service that we are going to use today, the Azure Web Apps and the Azure Static Web Apps. So those falls under the middle of this picture. So those are going to be the platform as a service, because we need to configure some of the things, but also we don't need to make a lot of changes as you'd have needed for things like virtual machines. So it's going to be on the platform as a service side of things. So talking about the application that we have here, so this is a basic MERN stack application that we have over here. So for the front end, which is accessible to the public, we have React.js application. So it's a simple employee record management application, which I have basically taken the sample from the official MongoDB website, and then I have made some of the changes and also added the different GitHub actions to make sure that the deployment goes smoothly. So that's the front end, React.js. And then for the backend, we have the Express.js, which is a Node.js framework, which is used to handle server side of the things for our application. And then finally, we have the database layer, which is going to be in MongoDB. So MonStack, these all fits really well because everything is in almost JS stack. So MongoDB also follows the structure over here. So that's a pretty simple layout. So front end React communicates to backend, which processes different information, which in turn communicate with our database, which has our employee records. So whenever we want to fetch the data, so React asks the Express.js API, and then the Express.js, the Node API indeed calls to the database, it make queries to the database, and then a database returns that to backend, and ultimately that goes towards front end, and that is what we see on our web application. So that's pretty much the layout that I want to cover. So now let us talk about the Azure App Service, so specific service that we are going to use today. So it's a fully managed, like I said previously as well, platform as a service by Microsoft Azure for hosting our web application. So Azure takes care of all the infrastructure, and it also helps you to scale your application, so you do not have to worry about, let's say, if you have certain rise in your traffic and you're serving it to a lot of users, then the scale out can become automatic. And also if you have less traffic, then you can scale in. So that is about the infrastructure. It supports a lot of different frameworks. It also has a built-in CI/CD support, so you can automate your deployment. And it not only supports web app, it can also be used to serve mobile application and also as a REST API. So you can follow more information if you want. Then I have linked the official documentation as well. The second service that we are going to use is going to be the Azure Static Apps. So think of it as Azure App Service, but mostly catered and specialized for static content. So let's say our front end React, which will, when we build the React application, ultimately we are going to get the static assets, right? Hi there. Uh, nice to meet you as well. So yeah, if you have any questions in the chat, please, I would love to answer those questions. So please, you can feel free to ask them in the chat, and I'd be more than happy to answer your questions while I am going through the slides, and we will just begin the demo in just a second. So like I said, first we have the web app, which was for our Express application. Then we have the static Azure static apps, which we'll be using to serve our front end, which is going to be in React. And the Azure static apps is mostly specialized to serve static contents. So it also has the CDN support, which you can use to cache your front end so that it gets to your users in a more faster manner. So there is very less latency, and you can distribute your static website in different parts of the world in those caching servers from the CDN. And it's an amazing tool. And especially if you want to deploy static contents only, so things like single page applications made with Angular, React, Vue, and all those things, it's a really good choice. But for backend and especially for APIs, Azure Static Apps is not the choice for you because it does not provide a runtime environment. So you need Azure App Service for that and not static apps. Yeah. So that is about the Azure Static Apps. And even this supports the CI/CD. So whenever you have code changes, GitHub Actions will automatically help you to deploy the changes to the cloud. All right, so let's go to the next service. And this is basically about the different ways you can access the different Microsoft Azure service. So first we have the Azure portal, which we will be using in this demo. We also have the CLI-based access, which we will cover in the Docker series that we have in this Global Hack Week itself. So after this stream, I also have a 3-part Docker track series. So first is going to happen today, and the 2 will be covered tomorrow. There we will be using some of the Azure CLI commands, not required in this demo, to be honest. And then we can access Azure from VS Code and a lot of other ways, such as REST API and PowerShell. So now let us quickly talk about GitHub Actions. So we covered the Azure side of things for the theoretical stuffs. Now talk about GitHub Actions. So GitHub Actions is a tool or a service by GitHub which helps you automate your software workflows right from your GitHub repo itself. So by workflow, you will understand what that means in a second. So basically, you can configure all the settings, all the code, and all the steps that is needed for your application to be deployed, to be built to be built and then tested if necessary, and then building, testing, and then ultimately even deploying those build artifacts. So whatever your product is built, your applications, once it's compiled and built, you can take those build artifacts and then put it in the respective cloud service provider service so that you can deploy it automatically. So all of these things, you can do this from your GitHub repo itself. So we just need to create a workflow file in our project folder itself. And then the steps and the jobs will be mentioned over there, and that will be carried out to make sure our deployment is reflected on the cloud service provider. So we don't need any third party or any other tool to deploy our process. So that is about GitHub Actions. So it defines different jobs and steps, which I'll just cover what they are in a second. And these are event driven. So based on, let's say, if you want to make sure that you create a new version of your application only if it is pushed to the main branch, then that is one event. So a push is an event to the main branch, and that will trigger this action. So you can configure a different kind of triggers. You can also trigger it manually by clicking a button, but mostly it's automated. So it's triggered mostly based on pushing or creating a pull request to some specific branch. So that is about GitHub Actions. And like I said, events can be anything such as post, pull requests, commits, specific labels, and you can build, test, and deploy directly from GitHub. All right, so let's quickly understand what are the different major things that we understand in GitHub Actions. So first, we have the workflow, which is basically, you can think of it as a collection of different tasks that you need to do in order to make sure that your application is successfully deployed to the cloud. So that is the workflow. So basically what you want to run So imagine you're running a node application. So what are the steps that you do when you do it locally, right? So we install the packages, and then we install the dependencies, and then we do command like npm run start or npm run dev, right? So that is what we do locally. So you define the similar steps in the workflow, and ultimately you connect it to your cloud service provider, in this case Azure, and then you give it necessary permissions. You define the credentials and the API key access, and then put it some of the configuration variables, and then deploy that build artifact to the workflow. So that is the whole file. So we need to create this workflow file in the GitHub workflow. We have a question: are we talking GitHub or Azure or all of them? So these are like complementary service. We don't need to use either of them. Like not exclusive. So we are going to use both in our case. So we are going to use Azure App Service to deploy our backend. We are going to use Azure Static App to deploy our front end. And GitHub Action is the gluing layer between our repository, where we have all the code for our front end and the backend. And that GitHub repository, we will also set up the GitHub Actions, which will deploy the changes automatically to GitHub. So we're going to use all of them. You'll see, you'll become more clear once we reach to the demo part. So we talked about workflows. We talked about events, things like commits, pull request, push to the main branch. So that is about event. So we have the event first that triggers the workflow, and then the workflow is composed of different jobs. So let's say we have job 1 and job 2. Jobs are nothing but a collection of different steps. So like I said, we need to install node, and then do packages install, and then we need to run test, we need to build, we need to do all those things, right? So those are like the different steps that we need to follow. And the action has each step has a specific action or a purpose or a command that it needs to follow. So these are the different jobs, and each job has, like I said, different steps, and each step has action. You will become more clear about this once we see the GitHub workflow file in the demo itself. And in order to run these different jobs, we also need a running environment or a compute resource, right? So these jobs are not going to run in our local machine, because we are uploading these files along with our code repository, along with our code to the GitHub repository, right? So these things are also, these steps or the jobs are also performed on things called GitHub Actions Runner. So mostly, and in most of the time, you will be running these actions, and that will be run in a GitHub Actions Runner. So those are like mini virtual machines or a container environment. So basically understand that GitHub Actions takes care of these steps. You don't need to provision a different virtual machine, or you don't need to provide your own compute resource for these jobs to run. GitHub will do that for you. So that's basically the server that runs our job. And now let's go to the demo, because we have done all the talkings and covered the theory part. Now let's go to the demo and see all of this in actions. All right, so before I pull up the demo, I really wanted to show you all this link, right? So let me quickly pull this up. Yeah, so like I said, this link was on the slide as well, and I also posted on the comments. So make sure that you go to bit.ly/mon deployment. So that's going to contain all the resource, and you can see that we have different steps. So if you have not already, please make sure to check into the event. That is super crucial for you to earn some points, and also to get you some ZSW exclusive stickers and other swags. So make sure that you register. And then second, if you already have not done that, and then if you also have not checked, I am sure you already have, but if you have not registered for the overall Global Hack Week event, then make sure to register for that as well. And like I said, after this session, we also have the GitHub, the Docker series. So it's going to be a 3-part series. The first part is going to happen today itself. So you can check the timings and the schedule and the registration info as well. So for the demo, the first thing that we're going to need is a Microsoft Azure account. So as a student, you all are entitled to get $100 for free. So that's a credit that you will get for free, and you don't even need to set up your credit card information. In most of the cases, you can bypass that. So you can click on this link, and then please just sign up with your student email, and then you will get access to Microsoft Azure, and you'll also get $100 credit. Like I said, there is no credit card required for accessing the Microsoft Azure service. So you'll get $100, and this will be more than enough to complete our demo, and also for a lot of your other personal project as well. Just make sure that you cancel or terminate all the service that you have used and you no longer need. Otherwise, it might use up your credits and it might run over soon. But make sure that you're aware of that. So that's gonna be the first thing that you'll need. Please follow the instructions. It's pretty simple, and then you will get access to the portal. And once you have already created an account, you can go to portal.azure.com like I shown over here, and this will take you to the homepage of Microsoft Azure. Let me zoom this in for a second, and here you will get introduced to the Microsoft Azure dashboard. You can see different services, the recent service that I've used. You can create a new service by clicking on create a resource, and you will get to see a lot of different service. I'll just come back to this in a second. And needless to say, you also need a Git and a GitHub account if you don't already have it. And if you want to test the application locally, which is not required, I'm sure not all of you might have Node.js installed on your machine, and that's super fine because we are going to use the repo code, which I already have, and we are going to run that in the cloud, right? Where our ultimate goal is to put that to a deployment server. So you don't need to have it installed on your local machine. But if you want to test the application, if you want to make changes and see how that affects your application, or if you want to just use that, then please make sure that you have Node.js installed on your local machine. And the next important step I would like to highlight over here is the MongoDB Atlas account. So make sure that you go ahead and create the MongoDB Atlas account. And by following the link over here, so this is all MongoDB is also an MLS partner. So you get $200 of credit for MongoDB if you are signed up with the GitHub Student Developer Pack. So if you are already a student, there is a good chance that you're also signed up to GitHub Student Developer Pack. And that way you can get access to that. Even if you don't have, then you can just go up and sign up to MongoDB like a normal user. Just go Google search the MongoDB or go to mongodb.com and just sign up. And even there you will get access to a free database cluster that we'll use. So if you are a student, you get more benefit, like you have $200 extra credit. But even if you then we are just a free tier database would be super fine. So that is what we are going to use in here as well. So that's about the MongoDB. And after all of this is done, we are basically ready to get started, right? So the first steps would be to clone the repository. And let me just quickly put in the repository link. So this is going to be just a second. Let me open up my GitHub. And this is the repo link that we will be using. I'm just also going to put this on the Notion page over here. Just give me a second. I'm not sure why I missed the link, but it should be here. All right. I'm also going to put it on the chat. So there you go. So this is the GitHub link for our repo that we have over here. Let me quickly refresh this. Yeah, so now you can see we have the repo link over here. Just make sure that you go ahead and clone this repo, right? So I have already it in my own PC, so I will not be doing the step. Just go ahead and clone this repo. Just go to your terminal and just type in git clone and then the repo URL. So you will be good to go after that. And also you can follow the README on how you can clone the repo if you have not. So if you scroll down, yeah, here is the step-by-step instruction on how you can clone and just basically get started with the application. I'm going to show you that in a second. So the next thing that I want you to do, okay, just a second. We have a question over here. Can you repost the Notion link, please? The older one is not working. That should not be the case, but again, okay, so this is the full Notion link, and I am pretty sure that this should be working. But again, let me check like mon/deployment. Yeah, I guess you might have some typo because even the shortened URL is working fine for me. So yeah, both bit.ly/mon deployment or the link that I just posted now should work fine. So please follow the post over there. And then make sure that you clone the application that I have mentioned over here. Okay, so the next step is to understand how the project is structured, right? So we don't just want to take this Yeah, that's good to know, Sikha, and happy that it worked. So the next thing is to understand how this project is structured, and I have created a README which you can read on your own, and that's pretty much self-explanatory. But even then, I am going to run through this for you all. So this is pretty much just a second, Monstack application, right? So we are gonna have the React as our front end, which is a JavaScript framework. Again, for backend, we again have the JavaScript framework as Express based on Node.js. And then we have MongoDB as our database, which we will create in MongoDB Atlas. And then for deploying the application, we are going to use the Azure Web App Service. This is going to be used for our backend. And for front end, we are going to use Azure Static App, which is more streamlined and more customized to deploy static contents, right? So once we build the React application or any other front end, then it's just plain HTML, CSS, and JavaScript, right? So we are going to use the specific service that is built for that purpose. So that is about the front end. So different technology stack, and this picture right here, this might be a bit overwhelming, but trust me, it's not. So like I said, first we have the React application, right? And we're going to serve it using the Azure Static Web Apps. That's pretty simple. And the client will be accessing this application. Pretty simple, right? And then forget about the things on the right side. So we'll just cover that in a second. So this thing is pretty simple. And then our backend, which is an Express.js backend, is served using Azure Web App. So that is our backend, and all the API requests from the client, which is deployed in static web app, will be made to the Azure Web App Service. Pretty simple. The front end, the back end, and the user is going to access the front end, right? And again, the backend, which queries our database for all our employee records. We'll see that in a second, how the demo application looks. So that's going to be MongoDB, and which is served using MongoDB Atlas, which is a cloud database from the official MongoDB team itself, right? All right, I hope the things on the left-hand side of the figure is clear. And now on the right-hand side. So this is basically us, the developer, or you, when you are deploying an application. So whenever you make any changes to your application, you normally track it with Git, and then you upload it to the Git repos like GitHub or GitLab, right? So you push the code to GitHub or GitLab, and now the extra step that we have that is different if you don't use a CI/CD pipeline is that we have a GitHub Actions over here. So when you make changes to your code and then you push the code to GitHub, now we will also have GitHub Actions, which defines the steps, right? So we covered about GitHub Actions earlier. It defines different steps that is needed to configure our application, basically to build, and then to build the artifact, to test the application, to build the artifact, and then to take that artifact, which is a build artifact, and that build artifact is what will be used to deploy the application to static web app. So in this case, if you do React build, then the dist folder that you have, right? So all the contents of the dist folder will be deployed to other static web apps automatically. Again, for the backend, in our case, it's a Node.js application, so there is no Express application. We don't build the Express, we just run it, right? So we're gonna skip the build part. So basically, the npm packages that is required with the application and the application itself, right? So we're gonna take that and push that to Azure Web App, and all of this is gonna happen automatically. I hope this picture is clear, right? And this will help a lot when we see the live demo. Right. I hope it's clear. Please let me know if this is very clear to you, or if you have any confusion. Please let me know in the comments so that I know if you are understanding this concept or not. Please trust me that even if you scale this to a large complex application, the fundamental of the concept of CI/CD is going to remain the same. So this is super important if you are especially looking to go into the world of cloud and DevOps, even in your career as well. So for the local deployment, here are the steps. Yeah, thanks to know that you understood that. So you can see the installation steps over here. I'm gonna follow the Notion page itself because it's more structured and it's really easy to understand from there. But even the README is comprehensive, right? And we have the structure. Basically, we have the application in Monstack example folder, and the server and the client is separated in the app folder. So we have the server code in app/server folder and client code in client/app/client folder. Good to know that you also understood. So good to know people understanding that. We have the different git ignore and readme files. So that's basically, and we are going to cover about Docker in my Docker part of series. So you can completely ignore this for now. even if you don't know what Docker is at the moment, it's totally fine. We're going to cover everything in my Docker series, which is going to happen today and tomorrow, like after the stream. So that is all about the README and the stack. So let's go ahead and open my VS Code now, because it's time to open VS Code. All right. So let me quickly open this project. Desktop, and then it was in my projects folder. All right, monster example. All right, so this is my let me minimize everything for a moment and close every files. Okay, so I hope the font size is clear to you all. And here, so like I said, our application is mostly in the app folder, and here we have the separate folder for our client. So these are all the React files that we will need. And then we also have server, right? And these are all the Express Node.js application file. So we need to configure a few things, right? So because our application, if you just try to go now and install the packages and run it, it won't work, because we need to do some configuration. And all the source code for our client, basically the React code is inside the src folder of client. Here you can see that we have different components like the navbar, the record, where you will see the list of employee records, right? So all those things, the different assets in this folder. You don't need to understand the code right now, but it's pretty easy and pretty simple as well. So you have the records. You don't need to understand this if you are not familiar with React, but if you are familiar, then this is a very simple application. So you'll get a hang of it. Basically, we comprise different widgets and elements to showcase our employee records. And then we also have for our backend, we have the routes, right? And here we have different API routes that that our client will be using to connect to the API and then ask for different records. So /ID. So this means the information of a particular employee. / will take you to all the employee records, and right, there is different like delete route. We also have a patch route to update the record. We also have a post route to create a new record. So basically the CRUD operations. I hope this is clear. Our goal here is not to build a Mon app in this case. Our goal here is to learn how to deploy already built Mon applications. So if you want to learn more about Mon and how you can write code to build your or develop your Mon application, I have provided some resources in the notes. Please follow that or check out any other resources. But here our intention is to learn how to deploy that, right? So once it is already built. So that is why I'm not going too much into the code here. So that is about the server. And in the outside, we have a few configurations in .env and docker.env, which are relevant for the Docker part of the series, not in our case. All right. So now let us quickly open the information, right? So here, let us see what we have, what we need to do. So we need to set up a config.env, right? So we need to set up a config.env, and we need to provide the Atlas URL. So this is going to be the database URL, so which we have to create now, because we need that for our backend, right? So we need a database for our backend in order to connect, right? So first we are going to deploy that MongoDB instance in MongoDB, and then we are going to provide the URI over here. And then we also need to provide the port where our backend will run. So by default, it is 50/50, but if you want to run in any other port, you can change the port over here. So let us go ahead and create this file. And here you can see that we need to create this in app/server directory, right? So if you go to my server, then you can see that I already have those two inserted over here. And then I've already posted the actual value of the Atlas URI itself as well. So I have already gone ahead and created the MongoDB, but I will show you all as well how to do that. So I already have that configured. Just bear in mind that I'm just skipping the MongoDB creation part over here. And then once I have that, then I can install the packages and run the dependencies, right? So I can show you that just a second. I can go to, first I need to go to app/server, right? And then I need to install all the packages. In my case, I have already installed those, so it does not take a lot of time, but for the first time, it might take some time. So you can see that we have all the packages in node modules folder. And now, since I have installed the packages, I can just simply do npm run dev to start our dev environment. And you can see that it basically runs the nodemon as a dev server. If you don't have nodemon installed, please make sure that you install nodemon using npm install nodemon -c. So this will install nodemon globally. And once you have that, you can run npm run dev. So now you can see that our development server is starting and the port is server is listing on port 5000. So that's super cool. Let me just quickly open here, and now let me go to localhost port 5050, and you can see that we get a message that server is running, right? So that was the default request, and we have a path called /record in our API, and that will give us the list of records in our database. So since I already before this demo added some of the records, you can see that we have a few records of our employees. So this means that our API is working fine. You can check more information on record.js for the different routes, right? You can see that we have /route/id, and if you go to server.js, then we have the /record route as well, which indeed uses the APIs in the routes folder. So this means our server is working fine. Server is working fine, and the server is running. But now what about the client, right? So let us go ahead and check out client. But before client, let us actually go ahead and learn how to create a MongoDB, because in this demo, I already showed you one which is already created, right? I just inserted my value over here. But how do you do that if you are going to do it yourself? So first go to mongodb.com or sign up with the student developer pack that I showed you, and just log into your account. Just give me a second. You can log in with GitHub or your Google account. It's gonna log in automatically since I already logged in previously as well. So here you need to first create an organization. So go ahead and create an organization if you have not already. Just type in whatever name. You can even use your own name. And once you are inside the organization, you need to create a project. So since I already have two of the project, I don't need to create one. But if you can create a new, click on create a new project. I'm just going to zoom in a bit. So here I went from here, and from organizations, I went to projects, and from here, so this is going to be GSW Mon, right? So I'm going to name my project, and you can just click on next. You can add text if you want. If you have any other members or people you want to give access to, you can use their email address, and then click on project, create project, right? So this is pretty easy. And then once you are over there, you need to go on create a cluster, right? Or click on database, and then you need to create a database cluster, which is basically a running instance of your database, right? So you can click on create a cluster and just give it a name. I'm not going to create right now because it's going to take some time, and I already have created one before, so I'm just going to use that. But if you have not, then please create a new one. So you can name your database. So this is going to be our GSWMon cluster, right? So please follow some of the recommendations, like GSW. You cannot use, I guess, dashes and underscores. And you can choose any of the cloud service provider, but since we are using Azure, so you can click on Azure. But please, this is not necessary, because this Azure is different from the one that we are going to use for our backend and front end, right? Because this is handled by MongoDB itself. So though it is on the same cloud service provider, this MongoDB is deployed onto their account, right? So using their account and services, we don't need to take care of this. And just select the region which is closest to your location. So since I'm based in Nepal, so India is going to be the closest one, and that will reduce the latency to your database request, right? So wherever you are going to host your application, make sure that the database region is also very close to that, so that the latency is reduced and the read and write will be faster in this case. Just give it some tags, and then you can click on create deployment. Please make sure to select the M0 instance, because that's the free one. That's the free one that will not cost you any money. The other one is mostly used for production environment. So if you're deploying a real application or have a startup or a business, then you need to choose the higher ones. But for our learning and hobby projects, M0 is totally fine. Just click on create, and after some time, about, I guess, 5 minutes or so, you will have your database ready, right? So let me quickly go back, and I will already use the one which I already have. So I'm going to use the sample mon, right? So here, when you create a database, it will also ask you for a username and password. So it will, please make sure to copy that password, because that is super important. So when you create a database, in that step, you'll also get the username and password. That is super important, and that we will need in our application as well. If you forget the password by any chance, just click on database access under security, and here you can create a new username and password. So you can add a new user and click on auto generate password to create a new secret password, and you'll need this information in our access. So once you have the database up and running, so click on so once we have that, right, so we are going to click on connect, right? So just click on connect, and just a second, click on connect, and then you will have different options, right? And the one that we are interested is drivers. So you can see that we can use the MongoDB drivers with Node.js and other frameworks that will help our backend connect to the MongoDB very easily, right? So the only thing that we're going to do is to copy this string over here. So that is the one thing that we need to do. And in cases, you also need to install the MongoDB driver in our terminal. So you can do that using npm install MongoDB. And once you have that, you need to copy this string. And please remember that there is one thing that is missing on this URL. So that is the database password. And you need to replace this thing or this part of the string with the actual database password that you just created, right? So when you created the database or when you added the user, you also added the password, right? So you need to replace this with the password, and please copy the entire string. So just copy the entire string and just go back to your code, and then under server and config.env, which is the file that we create, under atlas URI. So this is going to have to match the name atlas underscore URI equals to, and then the string that you copied just now, and just replace this with my password. You can see that I already have replaced this with my password. And please, I'm going to destroy the database after this stream. So there is no security breaks in here, but make sure that you put this under config.env. And now you might be wondering, this is a very secret information, right? So this is a super secret thing. Why are we putting it into our code? We are actually not. So this is just a configurable environment variable, and this is actually used by our routes. So if you go to record.js, you can see that just a second. Give me a second. If you go to database and connection, you can see that under the code, it is using the environment variable atlas underscore URI process.env, which is used to access environment variable in Node.js. And then we are passing in the name of the environment variable, right? So this name exactly matches the one over here. And we are not committing this to our GitHub repo. So this environment variable is only stored in our own local repo. Please, that is super important. One of the very important thing that you need to understand when you are deploying your application to cloud. You never commit or you never push your API secrets or your client key, not your client key, API secrets or any other important stuff or keys or credentials. You never commit those to your GitHub repo, because that will be shared to your partners in your organization, which you might think might be safe, but it is not. In most of the cases, you only want very specific people to have access to those keys. And this is your database URI, so you don't want to commit it. And that is why we put it in git ignore. So if you look over here, that I have .git ignore in the root of my folder, and then I have ignored the config.env file. And this way, whenever I make changes to my repo and I push that changes, anything in config.env is not committed to GitHub repo. That is what we are going to do. And I've also set up port variable where our server will run. So you can see that server is running on port 5050, but if you want to change that, you can just change the variable value from here, and the server will run in that new port itself. I hope this is clear, right? So our server is running. Now let's go ahead and check our client, because we need our server to run before the client. All right, so I'm going to do app/client. Please let me know if you get this part or if you have any questions with regards to this part. So now we are interested in client side of things. Since our server is already running, please don't close the terminal where your server is running, because your server needs to be actively running. So if you cancel this terminal, then you will not be able to access it from your client. So make sure that you open up a new terminal or a new window, and from there run your client commands. Cool. Thanks for that. I hope you understood it. Now for the client side of things, since now that our client is running, right, our server is running right on port 5050, that is running in our own machine. So it's going to be on localhost and not on our cloud server, which we will do in just a second. So you need to create a .env file for client. By the way, this step is also mentioned in our, if you follow the documentation, then we did this part, we did all of this part, we completed these steps. And now for the client side of thing, we need to create a .env file in app/client directory, and there you need to provide the API URL. So for front-end development, we are using Vite as a development environment for React. So it's a super cool it's a super cool debugging and also compilation and all those building stuff. So Byte is a super cool server for your React application or any other front end like Vue. So we are using that, and we need to provide the URL of the API. And since our API is already running on port 5050, right? So you can check that our API is running on port 5050. So we need to put that URL in .env file in client, which we already did. So now that is done, again, I need to do npm install in client, right? Since the packages are already installed on mine, so this is not going to take a lot of time. And again, let me check my package.json. So yeah, we do have the build script. So I'm going to do npm run build, which is indeed going to run the Vite command, and our application will be served by Vite in this case. And if I copy the link, and then just give me a second. So if I now do localhost 5173, yeah, you can see that the front end has loaded, right? So this is going to be the front end of our application. And since I already had some dummy data in our database, you can see that even I have 3 data records as well. So if you want to create a new employee, you can click on create. So let's say we have Sikha, right? So we are going to use that name. And let's say you are just for, this is just for example, right? So let's say you are a DevRel engineer and a junior DevRel engineer, and we are going to click on save record. So you can see that the database is updated, right? And you can even edit or delete that. All right. Thanks, yes, for the compliment, but I hope that I'm going in a good pace. Some of you might feel it a bit faster as well. I'm sorry for that, but we do have some time limitations, and that is why I have created the detailed information in the Notion as well, so that you can follow along even at a later point of time. For now, what I would really recommend you to do is to watch and understand. If you can follow along, that's great. But even if you can't, please watch the stream and then try to grab the concept that I'm trying to explain. Because right now, after this, we'll move to the Azure side of things, where you will actually create the services and then configure the different deployment settings. And it's going to be a bit more fast-paced. But the good thing about this stream is that this is being recorded, and also you can find this on YouTube and then MLS Twitch channel after the stream. So you can rewatch the entire recording at your own pace as well. So please bear with me, because we do have a time limitation and I have a lot of things to cover. So I'll try to go as slow as I can and as much clearly as I can, but please try to understand that. Yeah, thank you for the compliment, though. I will keep that in mind. All right. So that is about the front end side of the things. Right. So we have our front end running, we have our back end running. So looks like everything is working fine on the client side of the things. Like, so you just added some configurations. So in the client, we have the Vite API URL, and for the server, we added the config.env and we inserted the MongoDB at last. Yeah, good to know that you got that point. Yes. Thanks for following up and catching up, because I know this is a lot of stuff, but yeah, trust me that the lessons will be worth it. Okay, so now we have configured our server, we have configured our client, and we have also checked that everything is working fine locally. Please note that we do not commit any secrets to our GitHub repository. That is why we need to put those things in git ignore. And so is the case for, let's say, node modules, right? So these are just the packages that our application need to run, right? But when you deploy it to a server, those packages need to be on the server, and not, it will not be you don't usually, or you never actually commit node modules to your project repo as well, because whenever you want it, you build it from your package.js application, package.js file, right? Because it has all the dependencies that your application need. So whenever you want it to build, you just create a freshly new node modules from package.json, and that is what will be used for production. So you don't actually commit node modules as well to GitHub repo. And that is why, if you see, I have also put that in the git ignore file. So in any of the path in my repo, if it finds node modules, then it will be ignored and it will not be committed to the GitHub repo. Yeah. Okay. So that is about it. Now our application is running fine. So let us now go to Azure. All right. So we have created a database. We have created everything. So let us go to Azure. So for Azure, please go to portal.azure.com. Just give me a second. Yeah, so just go to portal.azure.com, And you must have access to this after you sign up for the Azure for Student account. You will get $100. And if you want to check the credit, just search for education or just click on the one icon you have if you have it in your home page. And here you will be able to see your credit history. So let me quickly show you mine. So you can see that I have like $96 left, and I have used like $3 or $4 of the credit, right? So the first thing that we need to do is to create the service for our backend, right? Because if I show you the figure that we have over here, you can see that for front end we need Azure Static Web App, and for backend we need Azure Web App, right? So, but logically it would be better for us to deploy the backend because front end depends on backend and backend depends on MongoDB. And since we have already created MongoDB, so we are good to deploy backend, right? And only after backend we will take care of the front end stuff. So let us go ahead and do that. So let us go ahead and create an Azure web application. So I'm going to click on create a resource, and then I'll search for web app, which you might find it over here. Or if you don't, then you can go to compute, and then it's not over here. I'm not sure why. Just click on search for web app. And here you go. You can see that you do have a web app, right? But not from marketplace. We don't want to create from marketplace. Just a second. It might be named as app service. Should be named as web. Yeah. So just search for web app on the topmost, and then here you will be able to find the app service, right? So we want to go for that. So we want to go to the section which has app services, right? So you can see that I already have one which is up and running, right? So just for a glance, I will show you the site as well. So you can see that my server is actually running since I already deployed it previously, but I just wanted to show the end result. We want our local backend to be also hosted and running like this in the server. You can see that we have a URL which is provided by Azure. By the way, you could also use your custom domain, but that is a different case. You don't usually want a custom domain is until and unless you are into a business or startup side of things. For a hobby project, this is totally fine. So it's going to be like this, and you can see that even from here you can access the record, right? So you can see that we have all the records, and even the one that we created just recently, right? Because it's using the same database. So even if I upload it locally, since the database is on the cloud and since the backend over here is connected to the same database, the database is also updated here. So that is our end result, but let us see how to create a one. So click on create, right? So let us create, and you need to select the web app over here and not the static web app, because that will be created in a second, in the second part. Okay, so the subscription is going to be Azure for students. I am pretty sure that's the only one that you have. Then there's no confusion over there. And then we need to create a resource group. So resource group is nothing but a collection of different Azure services related to your project. So in our project, we have the Azure app service as well as the Azure static web website, and both of them are related to the same project. So we are going to put them together in the same resource group. So we will create a new one. So this will be GSW Mon. So that's the resource group that I've created. Just click on create new. I hope this is clear. I'm just zooming it for a second. And here you can give it a unique name, right? So I'm going to do like GSW Mon demo, right? So I'm going to give it the name. And this is going to be like the backend, right? And not the front end. So I'm just going to specify that exclusively. And for runtime stack, you need to select what type of application stack you are using. Since we learned that web app uses a lot of different framework, right? It supports a lot of frameworks. So in our case, it's going to be Node, and you can select the one that is used to build your application. In my case, it's Node 20, and the operating system where your application will run. So if you, until and unless you don't have a very good reason you want to run it on Windows, please choose the Linux operating system as your production operating system, because trust me, like more than I guess 80 or 90% of the applications in the server are run on Linux operating system and not on Windows. So even though you develop your code on Windows, in production it is always like mostly, not always, but mostly run on Linux operating system. So your application will run just fine in Linux. So just choose Linux for now. And for the reason, like I said previously, just select the one which is nearest to your specific location. So in my case, it's going to be Central India or South India. So I'm going to choose Central India for now. And just select, now this is super important for the pricing plan, right? So please select the one which is which is indeed within your credit limit, because you can see that it is the free one is basically free, but it's very limited. You don't get much processing power with that, and also the CPU and the RAM will be very limited. So choose the basic B1 plan. I'll recommend that because it's about $13 per month, but it fits within your $100 limit, right? So choose the B1. I recommend you to it has 1.75 GB of RAM and virtual one core virtual CPU. So that's going to be more than enough for our application. And then for now, you can skip the deployment, networking, and other parts. You can check out them. What are the different services? We will configure the deployment, automation deployment in just a second, but we don't need that right now. And then we also have different network access. And for this specific case, we need to allow public access. Normally in production, please note that normally in production, we don't allow direct access for our backend, right? Because we only want our backend to be communicable by the front end. So only our front end can communicate with our backend, and normally users connect with the front end only, right? And the backend ultimately connects to the database. But in this case, since we are using limited plans, right, and also creating a virtual VPC or VNet in Azure, it's another topic, so it's going to take some more time to explain you that in this case. So I'm just going to open the access for now, public access. But normally, just as a note, and when you try to deploy it in production, just note that normally we don't do this, but for ease of our access and to complete this demo, we are enabling the public access. And you can enable the different monitoring settings like application insights and all those things. I'm just going to leave those at default because we don't want much complexity for now. And I just click on create and review, and then click on create. So this will also take some time, right? So like it should be done in 1 or 2 minutes, but let's wait for that. In the meantime, what I want to do is to create just static app, right? Because we are not configuring, we are just creating the service right now, because we will connect it to our GitHub code in just a second, right? So just don't worry. And you can see that the repo, like the service is already created. So you can click on go to resource, and here you have the backend, and it's just warming up, and it will give you a URL from where you can access that backend, and that is very important. All right, so this is all done, and we need to configure our environment variable for our API here as well. Because remember, do you remember one thing, that for even when we did it locally, right? So even when we did it locally in app, let me minimize the client, we created a config.env file, and we added this environment variable, right, Atlas URI, and that was ultimately read by the database connection.js file, and it was accessing this environment variable as Atlas URI, right? So since we don't have config.env in our GitHub, please remember that we don't have config.env in our GitHub because we have ignored it. So we are going to put this environment variable directly in our Azure App Service so that no one else can access it, and it's not even in our GitHub. So we just configure that environment variable directly, right? So I will go to settings and then environment variables, and then you need to create add in under environment variable and app settings. You need to create add, and the name is going to be Atlas underscore URI, right? And you need to insert the value, right? So since I've already created a database, I'm just going to copy the same value. So let me quickly click on that, and then I'm going to paste it over here. And you just leave the deployment sort settings at empty, because that is something when you have like different deployment staging environment. So if in production or in big companies or startups, you have like different environment like dev, and then test, and then finally the main or the production slot, right? So in our case, we just have one production environment, so we are going to leave that empty. So you need to create this environment variable, and then you need to provide it a value, and please make sure to add your password as well. Otherwise, your application will not work. So you need to provide in the full value, and then click on apply. And again, double click on apply to make sure that you save your changes. So now that that is done, we have added the environment variable that is needed for our backend. So now we can configure the CI/CD pipeline, right? So let me again show you the repo. So I already have the repo configured in my case, right? So I already have the main and then clean and then different branches over here. But to make sure that you all can follow along or at least understand, then I'm gonna create a new branch. Okay, I'm gonna check out clean, because that does not have the unnecessary workflows. Again, I'm going to um, sorry, let's forget about check clean. I will show you the new cleaner way. So that's going to be git checkout as b. So this is going to be GSW, and then this is going to be like Azure, right? So that's going to be my branch, right? So I have the branch over here, and you can see that I already have some workflow file, right? But because I already did the workflow part previously before the demo, so I already have that workflow files, but I want to remove this. I want to show you all from the beginning, so I'll just delete the workflow file. So make sure that if you are cloning my own repo as well, you create a new branch. Please make sure to create a new branch by using this specific command, git checkout -b, and then just delete the workflow file entirely. So once that is deleted, right, I don't want anything on my branch. So I will commit the changes, remove workflows, and then sorry, I have to add those changes, and then git commit remove workflows. And then I'm going to ultimately push this to the origin, right? Git push origin, and then GSW Azure. So make sure that if you have cloned my repo, you also upload that to your own GitHub profile as well. So the better way would be to fork this and add your own URL. But if you have not uploaded to your GitHub, it won't work. So you need to have this code in your own GitHub repository and not mine. So you can't run the GitHub Actions on my repository. You only have your permissions to run on your own repository. So please make sure that you upload this code to your own GitHub repo. So I'm going to do that. So I'm going to push this branch, which does not have any workflow file right now. Okay, so this is done. So now you can see that it has the new branch. I'm going to click view all branch, and let us go to GSW Azure, right? And here you can see that it does not have the workflow folder, right? So that is super cool. Okay, so this is what we have locally as well. This is the entire app that we have locally as well. So it has the client and the server. And please note that we don't see any config.env file over here, like I previously said and mentioned it a lot of times. Okay, so we have our application on GitHub now. So the next thing that we need to do is to create a pipeline, right? So let us try to do it from Azure, and then I will explain you what the workflow file looks like and what it does and everything else. So let us go to deployment and another deployment center. You need to select a source code, right? So if this is the first time you are doing this, you will be prompted up normally like you would get in Google sign in. So you will be authenticated with GitHub in this case, and you need to provide it all the permissions. Just click on allow and select the repo you want to give it to access to, and then you will be able to configure the source. So in my case, since I've already authenticated with GitHub, I don't need to do that. And I can just see that you can see that I'm signed in as my user, and I need to select my organization, GitHub organization. If you're part of any of that, by default, you would be the one on your own account name. So I'm selecting my organization name and then the repository that I want to use. So the name of my repo is Mon app deployment automation, and the branch that I want to use to deployment. Please make sure this is very important. So like we already discussed, GitHub Actions is based on certain events, right? So we need to make sure that you specify on which branch you want the event to be triggered, or the workflow or the build action to be triggered, right? So we want to make sure that whenever there is a change in, let's say, GSW Azure branch, normally in production you have it in your main branch, but just for this demo I'm creating a new repo, right? So I'm going to select GSW Azure, and it has already selected the runtime stack because we created that using creation process. And for the authentication, so this authentication is basically to ensure that the Microsoft Azure has all the permission to access your GitHub repo, and also that GitHub has all the permission to upload your build code or your application to Azure web app, right? So that is what we are specifying over here. So if you select, please don't select basic authentication because that is almost legacy. And right now we use user access identity, which is based on access tokens and OIDC providers. So that's the most secure way of authentication right now. So this will basically ensure that Azure has access to GitHub repo, and GitHub also has access to deploy it to Azure. So both way it is authenticated, right? And you can click on just a second. Yeah, you can click on create save. So once you click on create save, now you can see that the deployment has started, right? And what this will automatically do, if you click on refresh, right? If you even I don't need to click refresh, you can see that it added automatically a workflow file. So if you click on .github/workflows, that's a folder. So we have a .github folder, and inside that folder we have the workflows folder, and not in the main branch. I want to see in the GSW Azure branch. You can see that it automatically added one file. So this file was added automatically by Azure because we provided it the permission to write and view our GitHub repo. So it added a one file, right? And this file is the workflow file. So let us explore what this file has, right? So I am going to pull this code in my local VS Code, and I will explain you how and what this file does. So I'm going to do git pull, right? Just a second. It should. I will also need to specify the branch that I want to pull for the first time. So I'll do git pull origin GSW Azure. All right. So now you can see that I have the .github folder, and inside that I have the workflows folder, and inside there I have the YAML file. Okay. So this is what I'm going to explain. But let us quickly break out for 3 to 4 minutes. Let's just grab a coffee or water. I'll also be back in 3 to 4 minutes, and then we will continue the rest of the part. So for the rest of the part, we will see what this workflow does and how this automatically deploys our code to the backend, right? So we'll understand all of this. We'll see this in action in GitHub Actions, and after we configure our backend, we'll also configure our front end in a similar way using Azure Static Apps. So just stay tuned for a second. Let me know if you're enjoying this session and learning things, and I'll see you in a second. Just give me a quick break. Hello, friends. Welcome back. I hope you had a short break as well and grabbed some coffee or some water. So let us try to get back into things. So let us before I explain the rest of the code and the rest of the part, just quickly recapping what we did, right? So we cloned a sample one application, right, which showed some employee records, and you could edit that records as well. So we set up the server. We added the MongoDB URI as our environment variable, and then we started the server. We created a MongoDB Atlas to ensure that we have the URI that is needed for our server to run. And then we install the packages, we run the server. Similarly, for client, we added the API for our backend in the config.env file. So under client and then config.js, we are importing the white API URL, and that is what we are passing in the .env file, right? So that is what we're using. And we also install the packages for the front and we ran it, right? So we did everything locally. And then on cloud, after the creation of MongoDB, we created two different services. We created Azure App Service, which is the Azure web app to host our backend or the Express application. And then we also created the Azure Static Apps to host our front end, right? So that is all the things that we did up until now. And then we created a deployment center settings for our backend. So when we did that, we authenticated with our GitHub repo, and then it automatically created a workflow file. By the way, you could do this in a reverse manner as well. So instead of telling Azure to create the workflow file, you could do it manually, but that would have involved some additional steps, which would have taken some time and might be a bit complex for beginners. So that is why I've skipped those parts and instead opted for an option where Azure would create the file for you, and that is the file that we have over here. Okay, so let us try to understand the workflow file. So like I said, it's a YAML file. So it's simply a format for the file. So if you are going to work with DevOps and cloud, you are going to come across this file format a lot. So please make sure that you YAML, but it's pretty simple. It's basically similar to JSON, but not JSON, but it works on the principle of key value store. So first we have the workflow name, right? So this is basically the name that you will see on GitHub Actions when you run this workflow. So that's the name, nothing too fancy over here. Please, can someone in the chat let me know if the font size is clear for you all to see for the workflow file? Please, could you let me know that? That would be helpful. And I also think that that would make sure that you can read it smoother. Can anyone on the chat let me know if the font size is cool enough or right enough? All right. I don't see any comments, so I'm assuming the workflow file font size is right. Okay. And then for the jobs, like I said, we have, for first, we have the on part, right? So we have on. So this specifies the event trigger that we talked earlier, right? So we learned that GitHub Actions had several type of event trigger, right? So here we specify that the event will be triggered on push, right? And on which branch. So you can specify the branches on which the event will be triggered. So on push event to the branches CSW-Azure, right? So that is the event which will trigger this workflow. So if you push it to the main branch, this workflow will not be triggered. If you want to also push it, make sure that you want to trigger this when you push it to the main branch, then you need to add the other branches like this. But we are not going to do that here. We just want to see on GSW Azure. And the second one is workflow displays, and this will also allow you to trigger the workflow by clicking a button on the GitHub repo itself. So you have two different events over here. So first is on push to the GSW branch, and then we have also a triggering event by clicking a button. So that is the meaning of workflow displays over here. And here are the actual steps that is required to run this workflow. So jobs, like I said, is the collection of different steps, right? So first we have the build step, and likewise we have on the deploy step. So things that are on the same label are same. So you can see that the build is on the same label as deploy. So these are two different steps, and whatever is inside here, so these are different things. I can elaborate the meaning of button. You'll be more clear. Just a second. You'll be more clear about the triggering of workflow when I actually show you the GitHub repo side of thing. Please just stay with me for a minute. We are going to come back to that in just a second. Okay. I'm going to definitely explain that. So just remember that you can trigger the workflow like similar to when there is an event, right? So you push something to the GSW Azure branch, it's going to be triggered. Likewise, you can also trigger by manually by clicking on the button. You can see the button. I will show you in just a second. So we have different steps. So like I said, we have two different steps over here, like mainly the jobs, which are like the parent collection of different steps. So two different grouping of steps. First, we have the build, which will actually build our application, and then deploy, which will actually deploy the application to Azure, right? So first we have build, and like I said, these jobs need to run on a different runner, right? And this code, whatever steps we define here, and the code that is going to be executed is gonna be run on the GitHub Actions server itself. So that is why we are using on Ubuntu latest, which is gonna be the operating system that the um, GitHub Actions server will use to run our steps that we have defined below. So that's the operating system. You can check out all the options in the GitHub Actions official documentation, which I have linked in the resources. And then now we have the steps, right? So for the build job, we have different steps. The first is the checkout step, right? So this is a pre-built action, by the way. So you don't need to specify manual commands over here. So this action, basically what it does is looks into our GitHub repo and just uh, copies or just understand the context of the code. So it basically checks out our repo, and it now has the Ubuntu Linux server will now have access to all the files and folder that is inside the GSW Azure branch of the repository. So basically it get access to all the code in the repo. So that is what checkout does. If you want to learn more about the action, then you can control click on that specific action, and that will open a documentation link for that specific action, and you can see what it does and how it does and what are the different options that you have along with it. But we don't need to worry about that right now. So it basically just copies or gets all the code that is in our repo in the specific branch that you have. And then secondly, we need to, like we do in a local, whenever we run a Node.js server, right? So we need to do all the steps that we do locally, right? But for a production environment. So we need a Node.js installed on our machine, right? So since this is a Ubuntu server, so we are going to set up a Node.js, and it's going to be using the Node.js 20 version, right? So that is what we are doing in this step. By the way, for each step, you can mention the name as well for the step, which is optional. You can, and you might leave it as well, but it's a good practice to mention the name to describe what that step usually does, right? So for the third step, so we have now the operating system, we have the Node.js installed. So the third step would be to install the packages, right? So we are going to do that npm install. Since we already have Node, we can run the npm command. And we are going to skip this two part because this is a Node.js server. Please note that this is a Node.js server. And if you go to package.json, you can see that not for client, I wanted you to show for the server. So if you go to package.json for the server, you can see that we don't have the test, like test is that non-existent. We don't specify any test, and we just start the server, right? So what we are going to do is we are going to skip this part. We are not going to build. We don't even have a build. So I'm just going to cut that out. So that is how it will happen. And then once we have installed all the packages, so in our GitHub repo, there was no node modules, right? But this step will create that node modules inside the Ubuntu Linux server, right? So it will have our application code. It will also have the node module. So now our application is basically ready to be deployed, right? So it will zip whatever or package whatever was installed, so the code and the dependencies, and it will upload that artifact, right? So the next step will be using the actions upload actions, and it will use it will create a release.zip file. You can specify the name of the path of the file name that you want to install, right? So that is what we are going to do. But please we need to have a couple of changes in this uh, repo, right? So for that, what I really recommend you to go is to go and check out the workflow file in my main branch, because there I have the final workflow file, how these different files would look like. So just let me go to the code and just a second. So go to the main branch and just click on github.workflows. And here you have the final workflow file on how it look like. So we need to tweak a couple of changes to this workflow, right? So that is why we need to add something over here. So the first thing that we are going to add is path. Okay, so we need to copy this, and then I'll go to the on push and before Okay, just a second. I'm going to just format this pet. All right. Just a second. I'm going to check the label. Okay. Oh, it should be on the branches label. Okay. So what this will do is that it will trigger this workflow only when there is changes to this specific path, right? So first let us try to understand this. So it will push the or trigger the workflow only when there is changes to any files inside app/server directory, right? Because this workflow is for backend, right? So we don't want to trigger the workflow unnecessarily when there is a change in the client folder, right? So that is why we specify this path. And also we need to run this workflow whenever there is a change in the workflow file itself, right? So we can rename the workflow file as the one that we have over here. I'm going to just quickly do that. Okay, I'm going to rename that. And so whenever there is change in this specific workflow or the server.app, this is going to be triggered. So that is the first thing that we did. The next thing that we need to do is to add a working directory, right? So I'll explain you why we need to do this. So we need to do that because remember that our application is not in the root folder, right? So we don't have any package.json in the root folder. We have that inside app and then server, right? So that is why we need to provide the path to the server. So that is why we need to add a working directory over here, right? So I'm going to place it over here like this, right? So you have a working directory set up over here as well, right? You can see that working directory is set to app/server, and that is the path where our applications lies. So you need to provide it a path where there is package.json and all your node files. So we did that. And similarly for release, like zipping the artifact again, since once you do npm install, all the node modules will also be installed within the same directory. So you also need to provide the working directory over here as well. So for this step as well, we need to set up the working directory. And finally, when you upload the artifact, you need to provide it the path as app/server/release as lib, because again, once you build the artifact, it would again be inside the app/server folder. So you need to provide that path when you upload it. So that is all about the changes that we need to make in the pipeline, right? And for the deploy job, and now we have the second job, right? Again, so the first job is complete. So we did the build part, right? We install the dependencies, we bundle it into artifact with a zip file, and then to deploy it again, it will run on Ubuntu, right? And it will need build. This means that the build step has to complete, and it has to be successful in order for this job to run. So that is like creating a dependency on the job. So why would we deploy if there was a failure in build process, right? So we add this so that it happens serially. First build and then only deploy, and then we give it a production. So this is like the setting up an environment. So we give it a name. So you can see this in GitHub. I will just come back to this in just a second. And it needs some permission, so we just provide that. And then now let us come to the main part, which is steps, right? So we already uploaded the artifact, right? So remember that in this step, it uploaded the artifact to this specific path, right? It had the artifact in this specific path. So now we download the same artifact. So it uploaded the artifact, and now we download the same artifact that was built using in the build process, right? And we unzip the release.zip file, so it uploads the artifact. Again, all of this is happening inside GitHub Actions server itself. Just a second. All right, sorry for that. And now we are unzipping the file, and then we are now logging into Azure, because remember that we need to push this application to Azure Web App, right? Azure App Service, which is hosting the backend of our application. So that is why we need to log into Azure, right? Because how else would we deploy it to Azure without connecting to Azure? So we need to connect to Azure, and for that, it needs different parameters like the keys and the secret passwords. Like it would need the client ID, the tenant ID, and the subscription ID. And you might say this weird thing, right? So this is not your client ID. This is just a variable that stores your actual client ID, right? So I'll show you this now. And finally, just skip this for now. So it actually is connecting to Azure. And now once it is connected to Azure, the final step would use the web app deploy action. And then you need to provide the name of the Azure web app. So GSW Mon demo backend, right? So this was the same name that is for our web app in Azure, right? So the name needs to match, and slot environment in production, because we only have one production slot. But if you had like different staging environment, you could use that. And that is all that we need to do, right? So again, like I say, if you want to see the final workflow file, how it looks, just check out the main branch and it will have over there. Okay, so we made these changes, right? So we made these changes. So let us just commit these changes for now. Use the source control over here. I will add all the changes and updated workflow. I'm just going to commit this. I'm going to publish branch. All right, just give me a second. So that is now updated. So now let us see the different things. So first, let us clear your concerns about the action. So let me check if the changes are pushed or not. Yeah, so the changes are already pushed, right? So whatever changes I did, it is already over here, right? So now the thing that is interesting is the actions tab. So just go to the action tabs to see all the actions that your application is running, right? So this was the action that we ran 20 minutes ago, right? And it failed. You can see that it has a red cross mark, and that was intended because if you click on different steps, so basically so there was a question on elaborate button, right? So this is actually the button that you can use to trigger the workflow, right? So if I click on, let's say, the workflow file for just a second. So let us say like we have the workflow file name as Azure Web App Backend Pipeline, right? So if you click on actions, and then the name of the pipeline and especially the app was just a second, build and deploy Node.js application to Azure Web App, right? So if you click on this, here you can see that you get different options, and also you can click on any of the workflow file, right? And you can click on read on all jobs. So this is actually the button that will trigger the workflow again. So that is what I meant by button earlier. So I hope that makes things clear. So if we look into that, now we have two different jobs, right? That we specified in our workflow file, but it failed on the build step itself. So you can check all the logs, right? So all the steps will have its own specific logs. And you can see that under the npm install command, there was a error that it could not found package.json, right? Npm is not able to find the file because earlier we did not had the working directory setup, right? So it was actually searching for a package.json in the root directory, which was not present, and that was causing the error. But now we fixed that. So the new file, whenever was changed, so you can see that the build is successful, right? So it completed all the steps, it uploaded the artifact, right? It did everything, and now it is actually deploying that changes to the Azure, and you can see that the post is now completed, and you can see the URL for your application here itself. So you can click over here, or you can check the URL from the Azure itself as well. So overview, I'm just going to close that, and you can click on browse as well. So for the first time, it might take some time to load up, but after this, it will be very fast, and it will not take up this much of time. So I hope this works. And let us see if this does not work. And in the meantime, let us now configure our static web apps. So our backend is almost ready to start, and I hope that works fine. You can check the logs of your application from the log string tabs in your Azure web app. So it will display all the logs that you would have normally got in your terminal. You can check the logs here as well. So you must not forget to set up the Atlas URI environment variable, and then it should work. All right, so let us wait for this to run. And in the meantime, now let us go ahead and set up our front end. All right, so I hope that was clear. Please let me know if there is any questions in the meantime from the steps that I showed you. So basically, a workflow file was created automatically. If you want to understand more about the different options available here for these different actions, please follow the official Azure documentation, or you can just control click and then see the documentation for the specific actions as well. So we are just doing like nothing is super complex here. We are setting up Node, we are installing the packages, we are bundling that, and then we are uploading that to GitHub Actions server itself. And then in the next step, we are just downloading that artifact. We are unzipping the release.file. Now this will contain all the Node.js and the packages. We are connecting to Azure, and then we are deploying that to Azure Web App. So that is, can you report after you publish branch? Yeah, okay. Can you elaborate what do you mean by publishing branch in this case? Like, so please remember that I'm doing all of this in a GSW Azure branch. You can do it from any branch you have, but just make sure that you have the workflow file, the correct workflow file in that case. And what you need to do is you need to add the working directory. You need to set up a correct working directory over here, as well as you need to set up a correct path for your to upload the release zip, and then everything else should go fine. So like if you go to Azure, you can check the workflow file from your respective branch. So you can see that under GSW, I had this workflow, right? So I have the workflow file over here as well. And then this workflow was used to run the GitHub actions. And you can click on the tick mark to see the actions as well, or go to the actions tab. Okay, yeah. So whenever I commit changes to the repo, so you can see that in the workflow file, I have specified the branch, right, on which the event will be triggered. So whenever I commit changes to that specific branch, which is specified over here, and also the changes needs to be within this specific path. So it is only going to check the changes within the server folder or the same workflow file itself, right? So only if the changes is within the workflow file or the server folder, this actions will run. And this will basically just build the application and deploy it to GitHub. But now, just to cover up, let us try to understand what this secrets is, right? Because this was automatically created by Azure, right? So let us try to explain, like, see what that is. So if you go to settings in your repo, and under security, you will see, oh, okay, why did it fail to deploy? Because it was initially when Azure created, this is a really good question. So initially, when Azure created the workflow file for us, it was searching for package.json in the root directory, which we don't have. We have the source code for our node app inside app/server directory, right? So we need to specify the working directory exclusively in the steps that I've mentioned, right? So we need to specify the working directory in this step, as well as in the zip artifact, and also when you upload the artifact, right? Only then it would run. So that is why it was failing in the first time. But when we made changes to the workflow file, and then when we pushed the changes, it re-triggered the workflow. So it reran the workflow once again, right? So once again, it reran the workflow. And now, since the Azure GitHub Actions, the GitHub Actions can find the package.json and all the relevant files, it ran successfully. I hope that makes things clear. Okay. Okay, thank you for that. And for the GitHub secrets, you can see that under secrets variable, under security, you can see that we have a lot of repository secrets, right? And this was created by Azure for us. Not all of these would have been created for their repo, because I have configured some additional service and I have some additional repository secrets, but all the other services would have been created by Azure for me, right? So you can see that, like, I cannot see the value, but I can edit the value if I want, but I don't want to do that. It's because it was already added by Azure for me. But if you were going to do this manually, so let's say you wanted to create your own workflow file from scratch, you would have to add these secrets yourself, which we will do for our static apps, for our Atlas URI secret. Okay, so let's go to now to front end, right? Okay, have we created our front-end application or not? Seems like we have not, right? So let us go ahead and create a static application now. Okay, so let's go ahead and create a static application. Just search for static web app, and then we will click on create. And after this step, like, the session would be over. So this is almost towards the last part of our application, because we already have our backend up and running, right? You can see that on the URL, we got a new URL and the server is running. You can click on record to see the different record, and it's working totally fine, right? So that's working fine. And for our GSW mon, this is gonna be front end. So that is working fine. So I'm going to choose a free or a standard. It would also be fine. It's not going to cost you much, but you can also choose free. And now we will create a deployment settings from here itself. So for backend, just to show you the steps, I first created the web app, and then I added deployment settings later on. But for now, I'm going to configure the deployment in the first step itself. So I'm going to choose GitHub, and then for organization, it's going to be my name. And then for repo, it's going to be mon app deployment, and the branch is going to be GSW Azure, right? And for app location, so here you need to specify the app location, right? So since it's not .app only, but also .app/client, right? So that is where our front end is, and we don't have like API within the static app, and the output folder is going to be dist folder. Right? So if you remember, for React, output is going to be dist, but for different framework, whenever you do React build, right, it can have different folder where you actually get the static files, right? So for React, it's the dist folder. So that is what we are going to do over here. And I'll just click create and review and create. And this should create me the new deployment. Again, if I go back to GitHub and then to code, I should have a new workflow file for my front end as well. So if I go to GSW Azure, yeah, so you can see that now I have a new workflow file, right? So I also have a new workflow file for our static web app. So I'm just going to pull this on my local setup as well, so that I can make some changes that I need. All right, so you can see that we have the Azure static app over here as well. And again, here also you can see that some of the secrets were automatically added by GitHub, right? But we need to make some changes, right? And to see what changes we need to make, let's just look at the main branch, because that contains the final changes that we need to do. So the first thing that we need to do again here is also add path. All right, so let us do that on push. All right, so I have added the path over here. Okay, so this again, similar to what we have in server.js, right? So this action will only run if there is a changes to the client, because we don't want this action to run unnecessarily if there is a change for a backend. We want both of the things to be separated, right? So if we have changes in backend, only the backend pipeline will work. If you have changes in front end, only the front end pipeline would work, right? So let us also rename the static web app workflow, right? So let us rename that. Okay, I've renamed that. And then everything else would be same. Similarly, the process is very similar as well. So first we have the build and deploy. We just have like one job combining both the steps here. So unlike Azure Web App, where we had two different steps for like job for build and deploy, we combine that into the same step. In this case, we can do that as well. This is a really good use case to see how you can do same thing in different way. It again runs on Ubuntu. It uses the action checkout. Again, this is the same thing. It checks out all the code. It basically gets all the code that is in your repo, and then inside Ubuntu, and then it will use the Azure Web App deploy action. This contains all the necessary steps to deploy to your web app. But we need to make some changes. So that changes, let me show you that. So we need to add this step over here just after checkout. I will explain you what it does, right? Okay, so what we are doing, yeah, this is the front end workflow. You are correct, right? So this is the front end workflow. We already configured everything for our backend and it is working super fine. So now we are in the front end workflow. So we just created a static application. We connected the repo. We made sure that the workflow file was generated, but we need to make some changes. Otherwise, it would fail for the first try. So the first thing that we need to do is to set up environment variable, because remember in locally as well, there is a .env file which has the byte API URL, right? And we need that for our application to run. So that is why we set up the environment variable. We need to set up that before the build process is actually begun, right? Because you need this environment variable in the build process. So you need to do that before the build step. And again, here you are using the GitHub secrets, because you could actually hard code it as well, because like it's just a backend which would even be exposed when you are deploying this. It's just a static file, so whenever you make requests, the API will be exposed. But for the sake of demonstration, and also to make sure that whenever you have any secrets, you could use the GitHub secrets to encode that, right? So here, if you go to GitHub settings, you need to have these under your GitHub secrets. So go to security, secrets and variables, and then under actions, you can see that I already have the Atlas URI configured, right? Not the Atlas URI, sorry. We are talking about Byte API URL, right? And here you need to update it. If you have not created, then you need to create it. If you have created it, then you need to update it to the backend URL. So this was the backend URL, right? So if you go to the backend web app, right? So you will get the URL. So if you go to overview, here was the URL, right? So this is the URL of the backend. So this is the URL that you need to copy, and then go to your GitHub account, and then you need to paste this value, right? So you need to paste this value without a slash. Don't put the slash, um, uh, because I have already coded that in code. Remove the slash, and then under the byte API URL, just update the secret. Yeah, just update the secret, and then just verify it. You can use your GitHub password to update the settings. All right, so that is now updated. You need to make sure that the variable is there. So the next thing is that this thing will remain same, but I guess that's it. All right, we don't need to make any other changes to our GitHub code. I believe that. Just a second. Let me quickly confirm this with my main branch. I'm having weird issues with my mouse today. I don't know why. Let me check that for React. So we added the path, right? And then we also set up the environment variable. I guess that's it. Like, we don't need any other changes, because we specified the location of our client head, which is app/client, which is totally correct. And the output folder will be test, which is the case for React. Okay, so we made the necessary changes. So update workflow client. So this is going to be the new change. So now let me just quickly sync this. And now let us see if all of this works totally fine or not. Okay, so now let me go again back to the actions tab, and the new workflow should have been triggered. You can see that the workflow client was triggered, right? Okay, for some reason, even the backend workflow is being triggered, but that should not be the case. I guess there is some issue with the path that we provided. App/server, this is fine. And for static web apps, also that is fine. Okay, we'll check that like in a second. I don't know why. Oh, we made some changes to the env, so that is why I guess both the changes were triggered. Okay, so let us wait for this to complete. So build and deploy job. By the way, this job will also run if you open up a pull or close a pull request. So that is why we have that job. But you can see the different logs that is being produced whenever you run different steps, right? So you can see all of this. You can see that it is now using the npm install command, which you can see that we actually do use that for our application. So yeah, it's doing that. Okay, that is a good question. So, just to understand that, you can just check the section in the close pull-up request. So you can see that this is another job, right? And it will only run if it was a pull request, or if you open a pull request, or if you close a pull request. So that is the two time when this event will run. And it will, again, this will also run on Ubuntu. And then this will actually, when you build and deploy your application, you normally want to close the existing opened pull request, right? So this basically will so you have opened a pull request, and once you approve it, that will be like a final step for deployment. So this action will run, and then once you deploy it, so this, remember that this job is after the build and deploy job, right? So this will close the pull request, so it will automatically take care of your pull request as well. So that it basically close the pull request once the application is built, but only if this was a pull request. Yeah. But in our case, we are just committing the changes directly to the specific branch, which is, by the way, not a good practice. You should always, if you want to push changes to the main branch, create a feature branch, and then create a pull request, and make sure that you have the workflow triggered also on your pull request. And then the pull request will be automatically closed once the branch is merged and deployed. Okay, so you can see that this has succeeded, right? And you can see that we can visit our site from here, or you can also get the URL from, so if you go to static front end, you can also get the URL from here. So I guess, yeah, you can see that we are able to access our data. So our application is now deployed, and this is the URL that our application is running. I can delete the record, I can edit the record, so I can make myself as junior, right? So yeah, so everything is working fine, and that leads to the end of the demo for today. So I guess you all enjoyed the session, right? And I hope you all learned. Please let me know, like, if you have any final moment question. And I hope like this was a really helpful session for you. We basically covered a lot of different aspects, and the fundamental that I covered in the session is it's very vital if you want to go into the world of cloud and DevOps. And the fundamentals are always going to be the same, regardless of which tech stack or whatever software you use and you want to deploy it. The fundamental and the concept are always going to be the same. It's just that you will have some additional configuration, and you will also incorporate some of the best practices and security measures. But apart from that, you are going to be totally fine with getting started. Another good question: how can a beginner make most out of the session and future sessions like Docker? So uh, the best and the recommended way that I tell to all the students and beginners is to just do it. Just do it. So you watched my stream. I guess you understood some of the concepts. You might have not understood some of them. Rewatch the content. I have provided all the steps in Notion as well, and try to do it on your own. Just do it hands-on practice on your own. So you can take my own application, or even better, if you have your own application, you try to do it for yourself. You might encounter errors. Just ask those errors in Stack Overflow, and nowadays even ChatGPT will help you to solve a lot of those errors as well. Just ask in the relevant forums as well. Join some of the amazing Discord servers or that we have in MLS, or even the other community servers. Ask your friends and just watch more sessions. So after this, today, after I guess 3 hours, I have the Docker session as well, which is about containers. So right now we just deployed it from our source code itself, right? And we just bundle that into a zip. But even then, there might be some dependency issues and all those things. So in the world that we live today, we mostly deploy using container itself, and we don't usually deploy just the code to a virtual machine. We package it into a container so that we resolve a lot of these dependency issues, and also it solves a lot of scalability issues. So, and also used for microservices. So if you are interested in all of that, then I'm going to cover everything from basics, right? So you can join that session, and the most important tip for you is to do it in practice, and just don't be afraid to ask questions, and then you will be good. Just do hands-on project as much as you can. That is the thing that I would like to recommend. And also watch some of the conference talks. Like, this might sound too complicated, but trust me that like some of the talk sessions from CNCF or Docker or official channels of these amazing tools provide you some of the best resources as well. Yep. Thank you. That was amazing. That it's good to know as well, Sikha. I hope you had a lot of fun, and I hope to see you all in the Docker session as well, and also the Bob Ross event. I might have a wrong slide over here. It's not the Bob Ross event that I have in 3 hours. It's actually the Docker session that I have. I switched my sessions earlierly. So if you go to gsw.schedule, I'll just quickly show you that. gsw.io. Give me a second. Oh, sorry. gsw.mls.io. And if you go to schedule, you can see that for today, like after this session, at about 3:45 Nepal time, which is going to be like 3:30 Indian Standard time, we have the containerization session. So please make sure that you register, and I will be seeing you in 3 hours for that. And thank you. Bye-bye, and have a great time ahead. Thank you. Thanks for all the compliments, and I hope to see you also. Bye-bye.